just one of them. And then the one thing, I actually want to backpedal a little bit. I mentioned the catalytic triad, and specifically in that lecture, I mentioned histidine, aspartic acid, and serine. And I want to just add something, not to pile on Sunday's lecture, but also want to point out mechanisms, knowing a general mechanism. So if you think about the mechanism that was presented, protonate, make it a leaving group, so you break a bond, something nucleophile comes and makes a bond, and then deprotonate to get it back to normal. The catalytic triad, same thing. Protonate, make, break, deprotonate. Is that actually a pretty common mechanism? That thing? So how many, I mentioned specifically, and this was for cytochrome, catalytic triad is histidine, aspartic acid, and serine. I should have been a little more broad in mentioning that was for one specific example where the catalytic triad is a base, an acid, and a nucleophile. Every now and then, will there be something else? Could I do a cysteine maybe instead of a serine? There might be some specific enzyme that has a slightly different catalytic triad, but they typically have in catalysis protonate to make it a better leaving group. Nucleophile comes and kicks it out. Then the product's formed, the base deprotonates it, and it's back to normal. So the catalytic triad is basically a mechanistic combination. So how many know what the heck I'm talking about from that one amino acid lecture where I mentioned that? And I regret not going into more detail. Or what I regret is saying that I gave you this as a catalytic triad and most common one. But every now and then there's one that might do cysteine instead of serine, or selenocysteine instead of serine. And then every now and then there might be one with lysine instead of histidine. It's rare, but it could happen. And really, really rare, but there might be one that has a glue instead of it. But most often, this is your most common base, most common acid, most common nucleophile. Small steric hindrance, close to neutral pH. Okay, so sorry to use this as, oh, by the way, did you know trivia? But these are some trivia that they seem to like. Okay, onward we march. Which of the following is not a risk when exposing an implanted pacemaker to an external magnet? Oh my gosh, would they really put a passage on pacemakers on the MCAT? Oh yeah. So pacemaker is just genius device. Let me summarize it real quickly by saying it has a battery. Battery fills up a capacitor. Capacitor is hooked up to leads that are placed in the heart. Actually, let me do that color coordinated. The leads are thick so that you have very fast current to the heart. You have cycle, the filling cycle, the discharge cycle. You have down here connected there, and you have a resistor where it's connected like that. So basically, here's what's going to happen. Current as I've drawn it is going to come out here, go here, fill up your capacitor. So the capacitor fills. Once it's filled, it gets a magnetic signal, goes down here, connects here. Now the charge is going to dissipate this way. Then it refills, then it dissipates, refills, dissipates, refills, dissipates. So the faster you fill, the sooner it's going to dissipate, so you increase your heart rate. It fills at a different rate because this resistor can be connected at different spots. So it's high resistance, fills slowly, low resistance, fills quickly. But here's the key thing. When you have current, does current create a magnetic field? Is that one of the things you've learned? Charge and motion creates a magnetic field. So how do I know when this thing is completely full? No more magnetic field. Then it discharges. And so with that, it's got to respond to a handful of things. It's got to respond to O2 levels, CO2 levels, acetylcholine levels, adrenaline levels, everything. It's got to have all this biofeedback, and it also has to have its own mechanical feedback. When it's full, no field, so it switches down. Discharges, no field, switches up. So all these things are going on. One of the problems with pacemakers once upon a time was they would respond to outside stimulus, EM radiation, that would end up being of a comparable frequency to what it was detecting from the heart. And I don't know if you ever heard these stories, but in the late 60s, early 70s, when people would go, and of all things, the automatic doors at supermarkets happen to have a very similar EM frequency that it would send out, the wrong pacemakers it would hit and literally send them for a loop. It would information overload it. It would shut down and default to an 85 beats per minute survival mode. And so they started having to adapt accordingly. Okay, so that said, which of the following is not a risk when exposing implanted pacemaker to an external magnet? Number one, would a magnet put such a strong magnetic field here that the detection of field or no field, would that be hindered? And from what you know, how many of you have ever seen the signs in the hospital, in the MRI room or in the OCHEM building, the warning in the NMR machine, pacemakers not allowed? Is that a sign you've ever seen in a hospital? It is because massive magnets equal information overload for the switch, and the pacemaker will shut down. Interesting random fact I learned in class one day, because one of the students' dad was a pathologist. Her dad had to carry a massive magnet whenever he'd go to work or well on the job, because occasionally a corpse would still have a functioning pacemaker. I don't know how freaky that would be to you, but that would freak me out something fierce. Anyway, random, cool little trivial note. Number two, causing a pacemaker to deliver an irregular stimulus. So would a magnet potentially do that? Would a magnet introduce a magnetic field that it would detect and it might respond differently? It can. Okay. And by the way, I'm ignoring the passage. Some of the stuff could very well, if you're not knowing this, some of the stuff was straight out of the passage, so that has a cars element. But I'm just trying to do it on just life experience if I can. Cause the pacemaker to ignore the heart's own rate and deliver its own stimulus at fixed rate. That's one you'd have to get from the passage. That's like a default thing. I'm going to give it a question mark because I don't know that from real life. The passage, you'd have to know that. Have the pacemaker take on interfering EM frequency? How many agree a magnet is not giving off EM? So magnet can affect magnetism, but it cannot give off EM. So it's not giving off electromagnetic, so that is not a risk. Is this an information overload passage? I mean, I think this is one that's worth going through because it's a physical device that is based on physics, but has a huge role in physiology. Yep, just gives off a magnetic field. So it ends up, magnets don't have a frequency. They're just giving off a magnetic field constantly. Okay, moving on to the last one. Before the introduction of gels to hold DNA during electrophoresis, DNA was placed in a liquid sucrose density gradient, excuse me. And I want to stop for a brief moment. Does the MCAT ever do that, give way too much information leading into stuff? Yeah, by all means. Sometimes helpful, sometimes it's just there for noise. But I still want to figure this out. What do we use a liquid sucrose gradient or density gradient for? Is that really something we actually use? Is that involved in any technique? Do we ever centrifuge against that sucrose gradient? How many have ever heard that? You spin it out and it migrates through that sucrose gradient? Does that sound at all familiar from lab experiments? Or do we ever just have something migrate through that very viscous, resistive medium? Yep, it'll migrate through. How many agree that separates by size? Small things go through fast, medium, and large things go through slow. Okay. Wasn't successful in separating DNA of different sizes. They tend to run as one indistinguishable band. Why would they be one indistinguishable band? So not sure why, but I can start getting rid of things. Is it true that all DNA fragments have the same charge? They have the same mass to charge ratio. Longer strands will have a greater mass and a greater charge both. So in general, it's not completely true because some might be richer in the pyrimidines, some might be richer in the purines, and it's slightly different mass, but generally they thought about that. Not the same charge, but the same mass to charge. So that one's out. Diffusion causes DNA to clump together. Is that true? I don't think it is. I'm going to give it a small f because I don't know for sure. I don't think it's true, but I'm not 100% sure. The liquid sucrose density neutralizes the effects of the applied electric field. How many would say that's just crazy talk? I don't know why sucrose would do anything. Yep. So hopefully you recognize those bizarre answers. The viscous drag force generally increases with increased molecular size, meaning because they got so big, they all sort of just migrated together. Yep, bigger it is, more drag. Totally true statement. So that's good in that sense. I don't know if I fully understand why, other than because DNA gets bigger and bigger, drag force is going to slow it down, so it's just going to all sort of go as one band. So it just seems like the best explanation. How many like me don't really like that answer to explain it, but you do agree it's better than the other three choices? So is this a yes, that's a great answer, or is this a well, no, I guess so? It's a good enough answer. Perfect. How many have reached the point where you are totally okay with the no, well, I guess so approach? Yep, you have to be. It's not going to be often, but there will definitely be questions in the MCAT. You're going to have to do that. No, well, I guess so. Yep, and exactly. A 1 out of 2 guess beats a 1 out of 4 guess every time. Whittle down to what you can. I know I have 2 minutes. I was just looking at that. So I'm still going to try to go over that one and then just scoot as fast as I can. I'm basically set up where I need to be set up. So I just need to, and I've done all my prep work, so I'm feeling pretty good. But I am going to throw everybody out with the exception of the person who submitted the question, the WMC one, and oh, you're very welcome. And then the one who sent the proof.